Let's solve the question stock buy and sell with no limit. This question says that the cost of the stock on each day is given in an array price. Okay, each day you may decide to either buy or sell the stock I at the price I. You can even buy and sell stock on the same day. Find the maximum profit that you can get. Okay, this question, sometimes also known as stock buy and sell multiple transactions allowed. Well, in this question, you would be given an array. The name of the array is prices, and every ith price or every ith value denotes the price of a stock on that particular day. So it is like 0th day, first day, second day, third day, fourth and fifth day, as per this example array. And every ith value would be the price of the stock on that particular day. Okay, now what do we need to do? If you have even a little idea about the stock market, then you know that you buy at a lower price and you sell at a higher so that you can make profit, right? In this question, we have to do the same, and we need to keep in mind that we have a multiple transactions allowed. So here, let's see the sample test case. In this sample test case, as you can see, we are given the prices array containing the values 100, 180, 260, 310, 40, 535, and 695. Here we have the diagram, the graphical representation of the same thing. Now, what do we need to do? If these are the prices, then we know that the lowest price that we have initially, beginning up at 100, it is the lowest, right? So you are going to buy at 100. Then we have a peak here. Okay, this is a depth, or you can say this is a dip, and this is a peak. So you bought at this dip and you sold at this peak. What happened here? So you bought the stock at 100 and you sold it at 310. What is your profit? 310 minus 100, resulting in 210 profit. Now the next time you're going to buy your stock, again it would be at a dip, right? So here you can see at the fourth day, you have your stock going till 40. Okay, so immediately you saw that your stock is falling down, and after that it is going to rise. Then you can see, all right, you bought at 40, and then you sold at the peak again. That was 695. So once you do 695 minus 40, you have made the profit of 655. What was the total profit that you made in all of these days? You add these two, you get 865 as your total profit. Okay, seems simple, and it is. Here we can see one more example here. Okay, so you can see we have 4, 2, 2, 2, 4. 4 is actually not a dip. After that you have 2. So you cannot buy at 4, but you can buy at a dip. So at 2 it is a dip. It is something like this, right? Where you can buy once you encounter a dip. You encountered a dip here, so you bought your stock here. When are you going to sell it? The moment you get a peak. So here we don't have a peak, we don't have a peak, we do have a peak. Okay, because after that we do not have any of the elements in the array. So this is the peak, right, which is bigger, and the last value. So here I bought at 2 and sold at 4. What will be my profit? My profit will be 2, right? The answer is mentioned here. So the question is simple. Let's discuss the brute force approach for this problem. What we will do in the brute force is we will try to make on all the possible combinations of I and j. That means we can where we can buy the stock and where we can sell the stock. So every possibility that we have, we are going to try to make the profit out of it. So here initially for this approach, I have designed a recursive function in which I am taking up two parameters, start and end. Initially, my start is going to be 0 and my end is going to be 4 as per this array. So here, what do I have to do is, I have to loop using my I and j. Initially, my I would be here and my j would loop from this point till this point. Okay, my I would be traveling from 0 till one place before the end, which will be this one, and my j would traverse from I plus 1 to one place to the end, right? This one. So here, what do I have to do? I have to make all the possible combinations, and wheresoever I find a suitable condition. Now, what is a suitable condition? Well, suitable condition is that whenever my j is greater than I, and also the profit that the prices that I have, that means my prices j is also greater than my prices I. It signifies that I can buy on I and I can sell on j. That means I have a positive price difference here. So I will record the profit and I will keep the track of the maximum. And for every call, what will I do? I will try to calculate the profit and I will see what could be the maximum possibility on the left side. That means from the starting till I minus 1, and on the right side of my profit. That means from j plus 1 to end. Okay. So here, let's try to see this using a little example. Again, taking this one up, assuming your I is initially here at 0 and your j is here at 1. So what will be your current profit? You can see that 5, the value 5 is bigger than 1. Yes, you can record that. 5 minus 1 would be your profit. Plus, you will have to give this recursive call. Okay, in this recursive call, you pass on your array, you pass on the starting index that you have. The starting here is 0. And the ending index would be the left chunk. That means current I where you are at -1, -1. For us, it is going to be 0 minus 1, -1. Now this situation, and for the right chunk, what we'll do, j plus 1. J is 1, 1 plus 1, 2. And from 2 till the end, our end is 4 here. So for this one, you can see it is not a valid scope. That means we don't have this j greater than I. So now this would be already dead because we are using these loops. This would not run. So this would not process any of the answer. It would give us 0. So here, the calculation of this call is going to be 0. And when we make the call from 2 to 4, then the loops will run and you can have the profit as 9. How? You can buy at 3 and you can sell at 12 because we are talking about this chunk. We are on this chunk. We are ignoring this one because it is not giving us any, it cannot give us any profit, and we are taking this chunk in our recursive call. It is being calculated as 9. So total of all of these three values would be 13. So for this situation, I got my profit as 13. Now I need to create a result variable in which I will maximize my result. So initially I got a big value, I switched it. Okay, now it is 13. Now anytime I get a bigger value than 13, I'm going to replace this value. Let's just take one more example here. So here again, what happens when my j increases? Okay, in this situation, I is equals to 0 and j is equals to 2. That means my j has moved here. Okay, from this position, my j has moved here. Now, if I buy at 1 and sell at 3, then what will happen? My current profit would come out to be 3 minus 1, which is 2. And the first call that I have to put up, it is again going to be ARR, and from 0 to -1 because my start point is 0 and I is still at 0. And my next call would be the right chunk. That would be from the j plus 1 position till the end. Okay, so j plus 1 would be 3 this time because my j has increased now, and the 4 is going to be my end. Here, if I try to see, if I'm taking this chunk up of 3 and 4, then you can see if you buy at 8 and you sell at 12, you would only make a profit of 4. That is what we have here. 2 from this one, 0 because this is not valid, and 4 from this. Total comes out to be 6. But is 6 a bigger value than 13? Well, it is not. So that means we are not going to replace it. So in this manner, we are going to generate all the possible pairs and we will see what is the current profit of all of these values, and we will maximize the profit and result variable. Eventually, once all of the cases are done, we can return the result. But this solution is not optimized. Why? Because we are having these nested loops, and along with that, we have these calls, recursive calls inside it. So the complexity of this one is going to go exponential. So we would tend to avoid these many calls and these many like this much time complexity. So for that, we are going to move ahead to our next approach. So in this approach, actually is very intuitive. It says that whenever we are finding a dip, we need to see till what minimum point we can get. Okay, so assume your graph begins from here. Okay, and you encounter a dip like this, and from this point onwards your graph increases. So firstly, you have to calculate the buying point. Where will you buy the stocks? You will buy the stocks at the point of the dip. That means here. This point would be called as your local max or local minima. So at local minima, you are going to buy your stocks. How are we calculating local minima? We are just iterating the values till the point we reach that the next value starts increasing instead of decreasing. So we need to mark that up. And we are marking that up and we are naming it as local minima. Now, once we have calculated local minima, we are going to calculate local maxima ahead. Okay, how are we going to calculate local maxima now? We just need to see when we have an increasing slope. That means we see, okay, after this, a value is increasing, iterate, value is increasing, iterate, value is increasing, iterate. From this point, there could be a decline, but we are going to just check one step ahead. Okay, if a decline is coming, that means this is the tip, or this is the highest peak point that we have reached. We are going to mark this one as local maxima. Now that we have our both local maximum, local minima, I'm going to book the profit. How do I do that? I take the local maxima's value and I subtract the local minima's value from it. So whatsoever profit I have, I would store that. Next, when this iteration is done for the one time, again the next profit booking would go on. And once I have recorded the profit, I would again say, okay, I am seeing a dip now. Okay, so till the point I get the dip, I'm going to keep on traveling, and at the the most depth I have, or you can say the least value I have, there again I would get my local minima. All right, I need to keep traveling because after this the values are going to increase. This point would be considered as a local minima, the next local minima, and again we are going to find the local maxima. We'll see till what point the values are increasing. We will keep that as local maxima and we will book our second profit. And this process will go until our array is ended. Okay, let's see this with one example here, beginning up with 100. All right, so what do we need to do? We need to maintain the track of two variables, as I've already told you, local minima and local maxima. I'm initializing both of the variables with the first value. Now what do I need to do? Firstly, I need to calculate the buying point. For that, I need to calculate local minima. How do I do that? I see the declining slope. Where are the values declining? But here, if you see closely, if you take a closer look, you can see that after 100, we receive 180. Okay, that means the values are going up from here. That signifies that the place I'm standing at, this actually would be considered as the local minima. So once I've encountered, or once I've calculated my local minima, I would go for local maxima, and that will be calculated till my values are increasing. Okay, from 100 to 180, increase in value, 180 to 260, increase in value, and 260 to 310, increase in value. But here I can see after this point the value will decrease. That means I would consider 310 as my local maxima. Okay, so once I receive this value, I'm going to update my local maxima to 310. Now once I've done that, you know that your local minima lies here and your local maxima lies here. What do you need to do? You need to book the profit. How would you do so? You would just perform the calculation, 310 minus 100. That means 210 would be recorded as your profit. So total profit, initially it was 0. You would add 210 to it. Then you know that now you have calculated one profit. The point you are at, that is 310. After that, you have seen a decline. So the moment you start seeing a decline, you start that for the next transaction, you need to find out the buying point. You would go down 310, from 310 you would go to 40, and you will see again, okay, now the values are increasing again. So this 40 would be your next local minima, and then you would start calculating a local maxima. Increase in value, and the array ends here. So this would be considered as your local maxima. Again, you have to do the same. You need to do 695 minus 40, resulting in your 655. 655 would then be added here, and you would have your total profit as 655 plus 210, resulting in 865. So now you have seen, using this example of local minima and maxima, how you can solve this question. Now let's quickly see the code for the same. So you can see n is here, which we are keeping the track of the length, price is here. Then I have created two variables, local minima and local maxima. Initially, I have put the 0th value, the 0th index value of prices here, and I have calculated, I've made this variable result, which would be accumulating my profit. Okay, now how am I looping? I'm looping using this variable I, and I'm saying till the end of the array, I need to keep on moving. Every time I encounter a dip, okay, that means I am in the range and the prices I am at is actually greater than equal to prices I plus 1. That means this value is bigger than the second one. I'm having a dip. So till the point I am having a dip, I am going to keep on increasing. The moment I start increasing, at that ith value, I need to record it as the local minima. Once that is done, then I go on calculating my local maxima. I'll see, okay, till my values are increasing. That means I'm having an increasing slope. But till that point, I'm going to keep on moving. And the moment I see a dip, or you can say a decrease in value, at that point I'll stop. The ith value that I have is going to be the peak, and I'm going to record my local maxima there. So once the local maxima is recorded, I need to add that to result. I need to add the difference, or you can say the profit booked, to the result. Okay, and this will go on and on till the end of the array. And once the looping is ended, once we have iterated through our array completely, eventually the result would be holding my answer. That means the total profit that I have booked so far, and you can return that here. So we are having this complete loop in which we are going from 0th till the n-1th element of our array, right? Are we trading more than once? No, we are not. Are we doing any extra work? We are not. So what is going to be the time complexity of it? The time complexity would be order of n. You might see that, okay, you are using loop inside a loop, but make sure these are not repeating any values. You are just increasing the values, and you can see you are not coming back to any of the value again. So you now you know that the time complexity of this solution is going to be order of n. Are we using any extra space? No, we are not using any extra auxiliary space. Thus, the answer of time space complexity is going to be order of 1. Now let's see one more approach for it, and that approach is even simpler. So this approach says we know that we are allowed multiple transactions. So according to this approach, why don't we keep on buying and selling the moment we see that I'm able to make a profit? In the previous one, I was waiting till the dip and I was going till the peak. But this time, this process says that, okay, if the graph is going like this, you can do buy at that point. You see, okay, the stock prices are increased. You sell at that point. Then you again buy at that point. If you see that the next value is getting increased, then you again book your profit. You sell a here, you buy a here, and you again sell that here. You buy here, you again sell that here. The moment you encounter a dip here, you stop. Okay, that means because you are not making any profit, so you will stop. And till the dip, you would not do anything. But the moment the values start increasing, you can again start booking your profit. Okay, seems simple. Let's try to see, check with this example here. This one. So you are here at 100. The next value is 180. That means the graph is in this direction. Correct? Increasing. The moment you saw increasing, you will buy at 100 and you will sell at 180. What would be the difference? You would have made 80 as profit. Okay, so it will be added to your total profit. Next, now again you see, okay, the values are increasing from 180 to 260. You would buy at 180 and you would sell at 260. So what will be the case? 260 minus 180. Again, 80 profit. Just similarly, you're going to keep on traveling here as well, because you can see you are booking a profit here. So it will be 310 minus 260, and you have booked the profit of 50 here. Now you see, okay, after that you are encountering a dip. You're not going to perform the profit here. You're not going to perform the profit here. But just at the next step, you see, okay, the values are again increasing. Okay, 535 is bigger than 40. Then here what you would do? You would again perform your profit booking. 535 minus 40, that would be your 495 plus 495. All right. Again, at the last time, you can see that you are again encountering an increase in slope. So what you're going to do is you will do 695 minus 535, and you would book a profit of 160 again. Then you can you have calculated all the profit so far total, and you have completed your iteration. You can simply return the total profit that you have encountered, that you have calculated. Okay, so let's see the code for it. The code is here. We can see, okay, result again for us to keep the track of the profit. Then I've initialized it with 0. I'm going through each and every element of my array. I'm checking that whether the price I that I'm on, if that is bigger than the previous one. If that is bigger than the previous one, then I'm going to book the profit in the result. And I'm going to do this till the end of the array. Once I've completely iterated through the array, I can return the result. That will be containing my profit. What will be the time and the space complexity of the solution? Well, we are just iterating through our array once. That means order of n is going to be the time complexity. We're not using any extra space here. that means we will have order of 1 as space complexity. Okay, let's try running the code and see if it is passing all the test cases. So you can see the code is written here. Let's try to compile and run it. Okay, so it is giving us the expected output. Now let's try to submit that. Okay, so it is passing all of the test cases here. So I hope you have understood this question well. And this question was actually simple, but again, if you are in any doubt, then do give it a try, and try taking up your own examples, try run the code, work through both of the approaches. Both of the approaches are of same time complexity and space complexity. Whichsoever suits you, whichsoever you are able to understand better, you can go with that. Thank you.